Algebra 1 Common Core, Unit 6, Section 6, Inequality Systems Graphically. The previous section on 6.5, you learned how to graph inequalities, and the big thing there was that, instead of an equal sign, we have a less than, greater than, less than or equal, greater than or equal to, and instead of, it's not always a solid line. Sometimes we draw a dotted line, and then we also always shade to one side. Well, an inequality system, similar to a linear system, we didn't do any linear system graphs in videos, but we solved linear systems algebraically to determine where they cross. But we did graph lines in my class. We graph two lines, tell me where they cross, a linear system. Well, an inequality system, again, it wants to know what solution is in common. And so we're going to graph these, and instead of wanting to know where just the lines cross, I want to know where the inequalities cross. I want to know where the shaded regions cross. Because there's a lot of solutions here, not just one point of intersection. So basically, just like when you graphed linear systems, graph one line, graph the next, where do they cross? Well, here we're going to graph one inequality, graph the second inequality, and see where they cross. So it's nothing new. It's still just graphing inequalities, and you're going to graph them one at a time, but in the end, we're just going to kind of look at the picture and see, all right, where are they overlapping? So for the first inequality, I'm going to graph here. I'll graph this top one first. This would be a solid line because it's got the equal to bar. It's greater than or equal to. And the greater than tells me I'm shading above it. But my y-intercept is -1, and my slope is 2 from the 2 in front of the x. And that means up 2 over 1. Up 2 over 1, up 2 over 1, so on. And then I go and do that same pattern in the opposite direction. Because it's a solid line, I'm going to use my line tool to draw a solid line. I'll stick with the color blue. Oops, that's not quite there. Sorry about that. And throw some arrows on the end like we always do. And I'm going to shade. So this is a greater than, so I shade above. Now this is the area that's above it, so this is where I'm going to shade. But again, if you're not sure what side to shade, simply pick a test point. If I pick a point over here, it's going to work. If I pick a point over here, it's not. So if I pick any point in the coordinates over here, it's going to come out to be a true statement, and any point over here is going to come out to be a false statement. But greater than is above, and you can use the y-axis as a guide. This is the part of the y-axis that's above. So this is the side that I'm going to shade. And, shade however you'd like. We talked about this in the next video. You don't want to do too many, you don't want to scribble the whole thing. You also don't want to do too few. And your lines should extend the whole graph too, because this whole region, every point over here, is in the solution of that inequality. And we're going to label it. We're going to write y is greater than or equal to 2x minus 1. It's really important that you label because we're going to have a second one on there. Label, you should always label your graph. I didn't label these in the first video because technically you don't have to label when you only draw one graph. But if you're putting more than one graph on a grid, you have to label. All right, so I'm going to do the second one in green. If you have the ability to do different colors, I recommend it. But I also recommend you're using something erasable. So it's either different color pencils or different color erasable ink, because you are going to make mistakes. The most common is people draw that solid line when it should be dotted, and if it's in permanent ink, now you can't really fix the problem. All right, but this next one, I see a less than symbol, so that's going to be dotted and down. The dotted because it's not equal to, and down because it's less than. This one has a y-intercept of 2, so I start at 2, and its slope is -1 over 2, so it's down 1 over 2. The mistake or problem most students experience this is not graphing the first inequality, but graphing the second one, is because they kind of look at the first one while they're doing it. You have to pretend they have nothing to do with each other. So they're not interacting. I don't only draw my line in one part of the graph or anything like that. The biggest issue, I think, is probably the shading. That when people shade their inequalities, they tend to only look at, where it overlaps with the first one. But you have to pretend drawing the second inequality like that first one's not there. They have nothing to do with each other, and then when they're completely drawn, separate from each other, we look to see where they're overlapping. And so this time I'm going to shade down. Now notice that I shaded my first one with horizontal lines. That's just what I picked for the first one. For the second one, I'm going to shade lines with a different angle. Either I'll shade them vertically or I'll shade them kind of diagonally or something like that. You want to have your shading lines different for your two inequalities so it's easy to distinguish between them. Now when you're using different colors, it's not a big deal. But if you're using the same color and I do them both horizontal, it might be difficult to read it. So if you do one of them horizontal, do the other vertical, or one of them diagonally, and so on. So this one I'll do vertical lines for. And you see, so the mistake some people make is they'll kind of like do this. And they'll stop, but you're not drawing this in relation to the first inequality. So pretend this blue inequality isn't here, and everything below gets these shade lines. And now I can kind of look at it and see where's that checker pattern, which is also another reason why I like to do the different types of shading lines, one horizontal, one vertical, because it's very easy for me to tell that this region over here is the answer. And what we do is we put a big S in there, and the S stands for solution set. And so what we're saying is that's the answer. That's where these inequalities overlap. Any coordinates in this region will work in both inequalities. This is the solution. Now, we talked about in the last video that a point on the line is in the solution, but a point on a dotted line is not. So this point would be, all the points in here would be, this point would not. Where they intersect would not, because one of the lines is dotted. If both lines were solid, then on the lines and where the lines intersect would be in the solution, but nothing on the dotted lines, only in the regions for those. Okay, one more example here. This top one's not in standard form. First, let me move that positive 3 to the other side. I'll have to minus 3 to the other side. That's going to make it y is less than negative x minus 3. And this is a dotted inequality that's going down. Less than, it's not equal to, so it's dotted, and less than's down. So I'm going to start at negative 3 and have a negative 1 slope. Move this down a little bit. And dotted. And I'm going to shade down. I'm going to shade below it. I don't have to necessarily shade down, but I have to shade below it. I can shade down with vertical lines, but there we go. And I'm going to label it. Y is less than negative x minus 3. You could label it with the original equation if you'd like. I think I forgot to label this one over here. I'm going to label this one too. Y is less than, I think it was negative half x plus 2. Was that right? Negative half x. Yep. All right. So that one's done. The second one, again, I'll switch over to green. I'm going to have to divide everything in here by 2. Now that's going to make a y. This was a greater than sign. It still is a greater than sign. I only flip that inequality if I divide by a negative, but I'm dividing by positive 2. So I'm not going to change that sign. X over 2 is 1x over 2, so it's going to be a slope of a half x, and the 2 over 2 is 1. This is also dotted, but this time above. It's not equal to, so it's dotted, and it's greater than above. So start at 1 and go up 1 over 2. Same pattern, opposite direction. And while I'm drawing the second inequality in green, I'm completely ignoring the first inequality in blue. Now I'm shading above here. Now this is one where I'd probably like to draw vertical lines, but I'm not going to because I already did that. So instead I'll do kind of like diagonal lines like that. That's greater than. And this one has a small shaded region. It's just over here. But nothing on the dotted lines, only the points in this region will work, and not where they cross because they're both dotted lines. And that's it. A lot of times there's a follow-up question that says, like pick a point in the solution, or is this point in the solution kind of thing. You just kind of look at it and say yes or no. Remember, if I'm picking a coordinate like this coordinate over here, this would be the point negative 2, 1. Remember, you do x comma y, side to side first, and then up and down when you're stating coordinates. So this point is in the solution set. If I were to pick a point over here, something like, what is that? Negative 6, 0. That's in the solution. If you're asked to pick a point, pick something clearly in the solution. Don't pick something that something over here. It's kind of, maybe it's close to the dot. Pick something that's right smack in the middle, unless they ask you yes or no for a specific point. But that's it. Graphing inequality systems. See ya.